Relativity breaks its silence and comes back with updates about Terran R, Firefly continues operations of its Blue Ghost lander in some harsh lunar conditions, and NASA is going through quite a few workforce changes as of late. As always, we have all that and more coming up this week in Spaceflight. Continuing with the tradition from the last few weeks, we've got some lunar news to cover, and this first one is coming from Firefly's Blue Ghost lander, which had to beat the midday heat on the moon. Now, you might recall that the lander touched down safely on the lunar surface on March 2nd, just after the sun rose over the landing site at Mare Crisium. Its landing marked the first commercial moon landing and the first U.S. lander to touch down without issues since Apollo 17 in December of 1972. But as the sun rose in the sky and lunar noon approached, the temperatures climbed. At the hottest time of the lunar day, temperatures can rise up to 121 degrees Celsius or 250 degrees Fahrenheit. So to deal with this heat, Firefly planned to power cycle the lander to avoid it getting too toasty. By periodically turning off some of the lander systems and giving them time to cool down before turning them back on again, Firefly hoped to reduce the risk of all that heat damaging Blue Ghost. And it worked! A few Earth days later, the temperature started to decline, and Blue Ghost could therefore stay active for longer and longer during each cycle. And since 8 of Blue Ghost's 10 NASA payloads had already completed all of their mission milestones, Firefly kept only 2 payloads active during these power cycles. Meanwhile, Firefly and NASA updated us on some of the payloads. When Blue Ghost touched down on the lunar surface, NASA's SCALPS instrument had its eyes trained on the plumes of the lander's thrusters. SCALPS is short for Stereo Camera for Lunar Plume Surface Studies, and as its name implies, it's meant to study how the thruster exhaust plumes interact with the lunar surface in the last moments before touchdown. This week, NASA released footage from the 4 short focal length SCALPS cameras that captured the landing at 8 frames per second. We also saw the LISTER experiment drill into the moon. LISTER is NASA's Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity experiment, and it uses a gas-powered drill to take temperature measurements up to a few meters underground. Finally, we got a video of Blue Ghost deploying the Lunar Magnetotelluric Sounder. For this one, the lander shot 4 tethered electrodes out to its sides and extended a mast on its top deck. These instruments will help scientists study the moon's mantle by measuring electric and magnetic fields. This was one of the last 2 experiments on Blue Ghost that was kept active during the power cycling that I mentioned earlier. The other is LEXI, or the Lunar Environment Heliospheric X-ray Imager, which captures X-ray images to study how solar wind interacts with Earth's magnetic field. Blue Ghost will continue to operate throughout the rest of the lunar day until sunset on March 16th. Firefly hopes that the lander will continue to work on battery power for a few more hours after that, but then it'll be near the end of its mission, as Blue Ghost is not designed to survive the cold and dark lunar night. The lander also gave us a preview of what was to come this week, as many of us here on Earth also just experienced a lunar eclipse. While many were able to see it from Earth, Blue Ghost experienced the celestial event, but from the lunar perspective, of course, as the Earth's shadow covered the moon for a few hours. Blue Ghost stayed awake on battery power and captured the eclipse with its cameras. Of course, from its perspective, it saw a solar eclipse as the Earth covered the sun and left a glowing ring of sunlight visible in the sky. Here on Earth, parts of the eclipse were visible from Europe, Africa, Asia, and Australia, but the Americas got the best show. As the moon passed through Earth's shadow, it didn't go completely dark, rather it turned a dark orangey red. This was caused by sunlight scattering in our atmosphere, so in a way, Blue Ghost got to see the world's sunrises and sunsets at the same time from the moon. In more lunar news, over the last couple of weeks, NASA has made great progress with the agency's Artemis II mission, which is set to launch the first human spaceflight to the lunar vicinity in more than 50 years. Earlier this month, the Orion spacecraft, slated to fly on this mission, received its 4 solar array wings that will power it during its mission. The wings are attached to the European Service Module in an X shape, just like they were on ESA's ATV cargo vehicle. This was just one of the many pieces of hardware that need to come together to prepare for the Artemis II mission. Another piece of hardware on the move this week was the Launch Vehicle Stage Adapter, a conical adapter that will be attached to the top of the SLS core stage and connects to the rocket's upper stage. Now, if you've been following along for the last few weeks, you'll know that NASA has finished stacking the solid rocket boosters for the SLS rocket that'll fly on Artemis 2, which means that the core stage is up next. So it's no surprise then that this adapter has now rolled into the transfer aisle inside of the vehicle assembly building and will be attached to the core stage once stacked between the SRBs. On top of the adapter will be the Interim Cryogenic Propulsion Stage, also known as ICPS, which acts as the SLS upper stage. The ICPS is derived from the Delta IV Heavy upper stage and is manufactured by United Launch Alliance. The company built the ICPS for Artemis 2 a long time ago and put it in storage, but with SLS stacking well underway, this week the company finally delivered the rocket stage to NASA. The ICPS went from ULA's Delta Operations Center at the Cape out to NASA's Multi-Payload Processing Facility at the Kennedy Space Center. There, the stage will be fueled with hydrazine for its reaction control system before being transported to the VAB. But NASA's work isn't just engineering, it's also outreach. And as part of Artemis 2's public outreach, you should know that the agency is setting up a contest for the public to design a zero-G indicator for the crew to carry on board Orion during their historic mission. So what would you design? And who knows, maybe we'll even apply and propose our own. Relativity space has been quiet since the beginning of fall, but this week it broke the silence and came out with a bunch of updates on its Terran R rocket. Terran R's design hasn't changed much since the last time we heard updates around the middle of last year, but the company has been able to refine that design since then. In fact, they even say that they're undergoing the rocket's critical design review, which will finalize the rocket's design. In traditional programs, it's only when this review is complete that a company might start building parts of the rocket. But Relativity says what it's already reviewed and released makes up 50% of the rocket's mass, including its tank structures, engines, and other similar systems. This in turn means that Relativity has decided to go ahead and start producing those parts well before the review is done to get it to the launch pad sooner. The company has already begun building flight hardware, from Stage 1 and Stage 2 barrel sections and domes, to building and testing engines set to fly on Terran R's first flight. With Terran R, Relativity has also switched its methods of manufacturing rockets. While Terran 1 was more than 80% 3D printed, the company is now using additive manufacturing only where it makes sense in order to go fast and launch as soon as possible. This includes engines and other similar components. But for the tanks and domes, Relativity is using a more traditional approach. The tanks are built from stir-friction welded panels, and the company is outsourcing the dome construction to a vendor that already has that kind of manufacturing experience. Relativity is not shying away from switching to these other methods, and is in fact embracing it in the latest 42-minute update video that they uploaded to YouTube. Some of the design changes and details revealed in Relativity's latest update include a switch to non-retractable grid fins on Terran R's first stage, and the use of subcooled propellants on both stages except for the liquid oxygen on the first stage. The company also revealed that of the 13 engines on the first stage, 4 of them will be fixed, while the remaining 9 engines will be able to gimbal. The company aims to complete the first flight hardware of Terran R by the end of the year, with tests to follow in early 2026 at NASA's Stennis Space Center. Relativity also continues to prepare the launch site where Terran R is scheduled to debut in late 2026. That first Terran R flight will already have reusability components to it, as the company aims to test the first stage's landing capabilities with a splashdown off the coast of Florida. Terran R's first version, nicknamed Block 1, will be used as a test bed for those landings, eventually recovering one of those first stages on a barge at sea and inspecting it for future reusability upgrades. Further down the line, Relativity hopes for later versions to even be more reusable and more capable, with a high launch tempo of 50 to 100 launches per year. All of these updates come right as the company's major financial backer as of late, Eric Schmidt, takes the helm of Relativity, becoming its CEO and replacing Tim Ellis. Schmidt was CEO of Google between 2001 and 2011, and late last year he decided to invest part of his money in Relativity, something that's given the company quite a bit of breathing room to continue Terran R's development. As for Tim Ellis, he's still a board member of the company and still holds the title of co-founder, so we may still see him from time to time. With every new US administration comes at least some sort of change within NASA, and that's precisely what's been happening since the arrival of the new presidential administration nearly 2 months ago. Now, this change didn't begin with the cancellation of overly expensive contracts like SLS, Orion, or Gateway, though we are expecting that may come in some shape or form in the not-so-distant future, but rather it began with the downsizing of NASA's workforce. First, in February, as part of the Deferred Employee Resignation Program established by the Office of Personnel Management, NASA confirmed that about 5% of its workforce had accepted the resignation offer. This week, NASA continued to trim its workforce by initiating reductions in force, also known as RIFs, at the agency's headquarters in Washington, D.C. The agency says that these RIFs are to comply with 2 executive orders signed by President Trump on January 20th and February 11th. The first of these, Executive Order 14151, directs agencies and departments to terminate all diversity, equity, inclusion, and accessibility offices and positions. To comply with it, this week NASA closed its Office of Equal Opportunity, issuing RIFs for the 4 positions within the office. The second order, Executive Order 14210, directs departments and agencies to prioritize reductions in force at offices that perform functions not mandated by statute or other law. So, in order to comply with this order, NASA has decided to close and eliminate the Office of Technology, Policy, and Strategy, as well as the Office of Chief Scientist. These 2 offices will therefore disappear from the agency's headquarters, but individual centers will still have their own chief technologist. These workforce changes came right after rumors of budget cuts began to surface in the last few days. According to author and spaceflight journalist Eric Berger, who first reported on these, the upcoming presidential budget proposal, set to come out in a few weeks, could include cuts to NASA's science budget of up to 50%, with different scenarios showing different degrees of severity within these cuts. Based on some of the changes to NASA's science policies during Trump's first term, it's possible that the budget proposal may try to slash the roughly $2 billion allocated each year to Earth science. This cut would already reduce the amount that NASA spends in science by about 30%, with about $2.7 billion being spent on planetary science, $1.5 billion in astrophysics, and about $800 million in heliophysics. It's still not clear how far the cuts will go, but in order to reach a potential 50% budget reduction, these other programs would also probably see cuts as well. Now, of course, this is all still just rumor, and NASA's Associate Administrator for the Science Mission Directorate, Dr. Nicola Fox, said that she hasn't seen any information about these cuts as of yet. Normally, the president's budget proposal comes early in April, so we'll have to wait a few more weeks to find out what other things might be changing at NASA in the near future. But in the meantime, the U.S. Senate is working on a 2025 NASA authorization bill, which is coming in rather late given that we're halfway through the fiscal year. This authorization bill would authorize $25.5 billion for NASA in fiscal year 2025. Despite the latest changes coming from the executive branch, the lengthy 100-page bill largely keeps NASA's programs and projects untouched. It supports the agency's Artemis program, as well as the Moon to Mars initiative. It also supports NASA's efforts to maintain a continuous presence in low Earth orbit and keeping operations on the ISS until a commercial space station is available. But of course, authorization bills don't appropriate funding. That is, they're not actually giving the money to NASA to spend, but rather just recommending where the funding should go. In fact, what's ended up happening so far is that NASA was stuck with the budget from fiscal year 2024 for the entirety of fiscal year 2025. This is because Congress hasn't approved a new budget for 2025 and has instead had 2 continuing resolutions extending the government's operations through the first months of the fiscal year. And earlier this week, a 3rd continuing resolution was passed by the House that would keep the U.S. government funded through the end of fiscal year 2025 if it also passes the Senate. So all of this means that at some point, there's bound to be some back and forth between the executive and legislative branches of the U.S. government once the budget for fiscal year 2026 starts to take shape. It's not uncommon for this to happen, but it seems like big changes may be coming to NASA in the near future. So we'll be keeping our eyes not just on all that hardware, but also on the policies as well. Now we'll take a glimpse at some other stories across space, starting with Rocket Lab, who's still pushing for its own Mars sample return plan. The company recently published a video showing its plan to execute a Mars sample return mission as proposed to NASA. The plan would involve an all Rocket Lab-made architecture with a Mars transfer vehicle, a lander, a Mars ascent vehicle, an Earth return orbiter, and an Earth entry vehicle. NASA's Perseverance rover would then be in charge of collecting the samples and placing them on Rocket Lab's own Mars Ascent vehicle for return to Earth. The company claims this architecture would cost less than $4 billion and could return samples as early as 2031. However, this proposal isn't too far from what NASA estimated just a couple of months ago on its latest program review. The agency estimates that a commercial approach for this program would lead to a total program cost of between $5.8 to $7.1 billion, a cost that would include the $3 billion already spent as part of the Mars 2020 mission and the Perseverance rover. So, will this public pressure work? I guess we'll have to see what happens. This week, Kiko Donchev, SpaceX's vice president of launch, went on X to give an update on some of the recent challenges that teams have been dealing with within the Falcon 9 program and explained a few things that have happened recently. For example, in recent months, some of us more avid nerds have noticed that SpaceX was using the roll-on, roll-off barge that's normally used to transport fairings and boosters from Port of Long Beach out to Vandenberg a lot less frequently. According to Donchev, this has been due to bad sea states in the winter months, forcing them to instead go the old style of trucking this hardware via road, something that forces them to remove grid fins and landing legs from boosters for transport. The bad sea states have also driven up the refurbishment work and time. Additionally, the company recently lost a booster after landing, B-1086, which SpaceX's Bill Gerstenmaier confirmed was due to a leak of kerosene during the ascent portion that turned into a fire after the booster landed on the drone ship. Donchev says that as a result of that issue, the teams have taken the time to look at the booster fleet and have stood down for about a week to carry out this work. It's no surprise then that due to these challenges, SpaceX has now lowered its Falcon 9 cadence expectations for 2025 from more than 180 launches to 170 launches. But I mean, that's still a lot, so not like we're upset about it or anything. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. We're starting off the week with spaceplane news. On March 7th, the X-37B returned from its secretive OTV-7 mission, touching down on the runway of Vandenberg Space Force Base in California at 6:22 UTC. The spaceplane started its mission in the final days of 2023 when it was launched on a Falcon Heavy. It became the first spaceplane to launch beyond low Earth orbit into a highly elliptical orbit. Throughout its time in space, it performed several tests and demonstrations for the Space Force, including an aerobraking maneuver, during which it skimmed through the upper atmosphere to lower its orbit in October of last year. After spending over 434 days in space, this particular X-37B wrapped up its fourth and shortest mission. This was the second shortest flown by either of the two spacecraft and the seventh in the program. A Changzheng 3B launched from the Xichang Satellite Launch Center in China on March 9th at 17:17 UTC. The rocket lifted a classified satellite for testing communication technology into geostationary transfer orbit. A few days later, on March 11th, a Changzheng 8 launched from the commercial side of China's Wenchang Space Launch Site. The payload on this mission was a batch of 18 communication satellites for the Qianfan constellation of internet satellites, which is also known as G60 or Space Sail. The next day, Falcon 9 took to the skies in California to launch two science missions for NASA. The first of these is the Spectrophotometer for the History of the Universe Epoch of Reionization and Ices Explorer, or SPHEREX for short. The telescope will survey the sky in search of the source of the universe's early inflation and organic molecules throughout the universe. The telescope features a distinct set of cone-shaped photon shields that keep the spacecraft's sensitive infrared instruments cold. 4 suitcase-sized satellites for NASA's PUNCH mission also hitched a ride on this launch. PUNCH is short for Polarimeter to Unify the Corona and Heliosphere, and as the name implies, the mission will study the Sun's heliosphere and corona. Falcon 9 lifted off with the 5 satellites on board on March 12th at 3:10 Universal Time. The booster on this mission, B-1088, flew for the third time and landed successfully at Landing Zone 4. On March 12th, the European Space Agency's Hera mission flew by Mars for a so-called gravity assist. The spacecraft is on its way to study asteroid Didymos and its companion Dimorphos, but it needed a little help to get onto the right path. That help came from the red planet, whose gravitational pull changed Hera's trajectory as the spacecraft flew just 5,000 kilometers from the planet's surface. As Hera swung by Mars, it used 3 of its science instruments to observe the planet and its moon Deimos, which Hera passed by at a mere 1,000 kilometers. This provided an excellent opportunity for the mission scientists to test the performance of these instruments, and it gave us some amazing pictures too. We also had a Starlink launch from Florida this week. Falcon 9 lifted off at 2:35 UTC on March 13th, carrying 13 Starlink direct-to-cell satellites and 8 regular Starlink V2 mini satellites into low Earth orbit. Booster B-1069 flew its 22nd flight on this mission, and it landed successfully on the deck of SpaceX's drone ship, a Shortfall of Gravitas. With this mission, SpaceX has launched a total of 8,085 Starlink satellites, of which 990 have found their way back to Earth, and 6,409 have moved into their operational orbits. Closing out the week, we had the launch of the Crew 10 mission to the International Space Station. The mission was originally supposed to launch earlier this week, but was scrubbed due to an issue with hydraulics on ground support systems. But on its second attempt, on March 14th at 23:03 UTC, Falcon 9 lifted off from historic Launch Complex 39A with Crew Dragon Endurance on top. The commander of the crew of 4 is NASA astronaut Anne McClain, who was accompanied by the mission's pilot, NASA astronaut Nicole Ayers, and mission specialists JAXA astronaut Takuya Onishi and Russian cosmonaut Kirill Peskov. Dragon is set to arrive at the station on March 16th at 3:30 UTC. Following this, the crews will take part in a short handover period during which the previous crew will help the new arrivals familiarize themselves with life on board the space station. Crew 9 will then depart the station on March 19th. Crew Dragon Freedom will undock from the ISS with Nick Hague and Alexander Gorbunov on board, as well as the 2 Starliner astronauts Butch Wilmore and Sonny Williams. Freedom will return to Earth and splash down off the coast of Florida. If the schedule holds, March 15th promises to be a very busy day with 5 launches if you set your clock to UTC. The first of these will be an Electron mission from Rocket Lab's own spaceport in New Zealand. This launch is set to carry a synthetic aperture radar satellite into low Earth orbit for the Japanese company IQPS. The mission is dubbed The Lightning God Reigns and is expected to lift off during a 2-hour window opening at midnight UTC on March 15th. Next, we'll have a launch from China. Around 4:10 Universal Time, a Changzheng 2D is expected to lift off from the Zhochuan Satellite Launch Center. For the next mission, we'll go to California, where a Falcon 9 will launch the next transporter mission of SpaceX's small-sat rideshare program. This mission is set to carry dozens of small satellites, including a number of science missions, into sun-synchronous orbit. Transporter 13 is scheduled to lift off during a 46-minute window, opening at 6:39 UTC. Over on the other side of the country, we'll also have a Starlink mission on March 15th. Falcon 9 is set to carry another batch of Starlink direct-to-cell satellites into low Earth orbit, lifting off from Space Launch Complex 40 during a 4-hour window opening at 10:28 UTC. Just 2 minutes later, the window opens for an Angara 1.2 launch from Plesetsk in Russia. The payload on this mission is a Russian military satellite. On March 17th, a Series 1 is expected to lift off from Site 95A at the Zhochuan Satellite Launch Center in China. T0 for this mission is scheduled around 8:10 UTC. Then back in New Zealand, another Electron is set to take to the skies on March 18th. This launch will deliver the final batch of Internet of Things satellites into low Earth orbit for the French company CASC. With the addition of these last 5 satellites, the constellation will be completed after 5 launches. So, Rocket Lab fittingly named the mission High 5. Liftoff is expected at 1:31 UTC. Later that day, SpaceX plans to launch another batch of Starlinks from Florida. The 4-hour launch window for this mission opens at 18:09 Universal Time on March 18th. For the next launch, Falcon 9 is expected to lift off from California on March 20th. The payload on this mission will likely be the next batch of Starshield satellites for the U.S. National Reconnaissance Office's proliferated architecture. This mission is set to lift off during a nearly 2.5-hour window opening at 6:02 Universal Time. Back up on the International Space Station, another vehicle is set to depart next week. On March 21st, at 11:35 Universal Time, the Cygnus NG-21 cargo vehicle will separate from the station. Its final task will be to dispose of waste as it burns up on re-entry in Earth's atmosphere. And wrapping up the week, we'll have another launch from China on March 21st. This will be another flight of Galactic Energy's Series 1 rocket, and it will lift off around 11:10 UTC. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.